Hi, good morning. My name is Vivek Singhal. I am a co-founder and chief data scientist at Cellstrat. We are an AI startup based in Bengaluru and Delhi, and we deal with AI, machine learning, and deep learning. Okay, so let me just start here. So just a brief plug on a startup. We do research and training in AI and machine learning. I am also a trainer. I teach people machine learning, deep learning, and artificial intelligence. We have set up a AI research lab here in Bengaluru. We are working on cutting edge innovation in artificial intelligence areas like computer vision, natural language processing, reinforcement learning, self-driving cars, and so on and so forth. And we are very active in social media communities. We are interacting with global AI experts for a variety of innovation. Okay. So this is our founding team. Myself, Vivek. I am a data scientist and co-founder, and I am an AI advisor to multiple corporations like Manipal Education Group, Simply Learn, ITC, HSBC, and many others. And we do seminars and webinars for companies as well as communities. I am a serial entrepreneur. I was in US for 16 years, working for firms like AT&T and Schlumberger. And after coming back to India in 2012, I was a director at IBM Global Services here in Bengaluru. And the last 4 years, I've been trying a couple of startups. The Strat is my latest startup in the AI space. And we have my co-founder Vishal, who's not listed here, is based in Delhi, and we have some senior data scientists who help us. People like Prabhas Thakur, director of AI practice in Central. Okay, so two co-founders and a team of senior data scientists to help us. The two co-founders are Vivek and Vishal. Vishal's profile is not listed here. He is based in Delhi. Okay, so I'll just introduce AI ML very briefly. I'm not going to cover all the aspects of this PPT I'm showing here, and we don't have so it's a half an hour session. So I'll briefly describe what is AI and machine learning and what kind of careers we can expect in this space. Okay, so let me jump right in. So, Andrew Ng is the former chief data scientist at Baidu, and now he's also a professor of computer science at Stanford Computer Science Department. He was also from Google AI team beforehand, and he has said AI is the new electricity, and this sentiment is now echoed by folks like Sundar Pichai or Satya Nadella, and they used to say we are mobile first. Now all of them are saying we are AI first companies. So AI is very impactful because with AI you can do literally magic or almost magic. So you can predict stuff like you can predict stock prices, you can predict portfolio distributions, you can predict house prices, you can predict vision, you can predict intent in speech. So AI is magical in that sense. It has tons of interesting applications. And why AI is proliferating? Because of the new data economy. There's massive big data available now, right? As we know, there's a lot of big data going on. And because of big data and also some of the computing prices have fallen with the advent of graphic processing units from companies like Nvidia, AMD, and Intel. We are able to do low cost, high performance computation. So this between big data and cheap semiconductor chips, we are able to see advent of AI. Okay, so AI needs data for training, and it also needs very high performance computing clusters of computers or cloud computing, and also cloud computing is available to do high performance computing. So and also the big data and computing, between these two factors, AI is proliferating. And as you can see in the middle diagram there, that companies like Google and Amazon are collecting a lot of data on global consumers, and with this data they are able to drive more personalized services, and using these services they are able to get even more users for everything they do. So there's a data network effect. So there's a network effect in motion here. The largest data generating companies are able to drive more personalized services, and hence, drive more, user generation, and these users generate even more data. So that's why the regulators are now stepping in worldwide and trying to check the power of technology companies. Okay, so it's a very exciting area, but yes, some of the largest tech companies have quite undue power in this space. So the regulators are stepping in and trying to throttle the growth of the top tech companies, if you will, so that they don't become monopolistic. So just to get our basic definitions out of the way, what is artificial intelligence? Basically, we simulate human intelligence. So at the very basic level, artificial intelligence is about simulating human intelligence, right? And so just like humans are the most intelligent beings on the planet, we are trying to train machines to think in a similar manner. And some of these applications include robotics, vision, image, self-driving cars, text analytics, gaming, AI in retail, financial services, credit scoring, fraud, I mean, n number of things, chatbots. So the applications are quite countless. And in the picture there, you can see the IBM Watson robot. IBM always has this robot at their conferences, and it uses their Watson supercomputing platform, which is now an AI platform. So what is machine learning? Machine learning is a branch of AI, and this is machine learning refers to a set of data science and mathematical techniques which allow us to train, artificial intelligence. So, so sometimes we use the terms AI and ML interchangeably, but technically ML is a branch of AI, and it refers to set of mathematical techniques, things like regression or classification or decision trees. And those of you who work in analytics might be familiar with these, or time series analysis, and so on, and vector and matrix algebra. So those of you who work in statistical domain, or even business analytics or data analytics might be familiar with this terminology. So we use those algorithms to train artificial intelligence. Okay, so machine learning trains machines by observing historical or past data. Okay, so that's how we train AI, by feeding past data, that could include input and output values. For example, if I'm trying to predict house prices, I have to feed historical data. What will the historical data contain? The factors which influence house prices, which is X. The factors could be age of the house, the size of the house, the city the houses are in, the quality of the builder, and so on and so forth. And what would be Y, the output? Output is simply the price of the house. So we are able to reverse engineer or learn the relationship between input and output, correct? So the point of machine learning is we are learning the ideal weights in this equation. Okay, we are learning the ideal weights in this equation, and the weights refer to the weights and bias here. So now, of course, X could be a more complex feature. It need not be just one feature. As I said, in house price regression, I have multiple features like age of the house, size of the house, and so on. Okay, so we are able to reverse engineer or learn the relationship by between X and Y by having, let's say, million house samples from the past, correct? And then once I know the relation using the machine learning training process, this we call as the learned or trained model. We deploy it in production to predict future house prices. Okay, so this is how machine learning works in effect. Now let me go on to the next form of machine learning, which is called deep learning. What is deep learning? It's a specialized form of machine learning. It uses networks of interconnected units called neurons, which you see in the diagram on the right. These are called as artificial neural networks, and these are modeled on the concept of human networks of the neural networks of the human brain. So the word artificial is the fact that they are as opposed to biological neural networks of the human brain. And interestingly, this inspiration was provided by the biologists or biomathematicians or bioinformatic professionals when they were studying human brain and how it uses complex neural networks to do information processing. And so the computer scientist said, well, we can apply a similar logic for complex decision making in artificial intelligence. Okay. So this specialized form of machine learning is referred to as deep learning. It's very useful for more complex applications like image processing, speech recognition, self-driving cars, gaming, and etc. Okay, and if you notice in the diagram on the right, uh, I call it a divide and conquer mechanism. The way neural networks learn is that they divide and conquer the task. So the task here at hand is object detection in this image, and the pixels of this image form the input layer of the neural network, and the first hidden layer detects the edges. For example, this is an edge, this is an edge, this is an edge, correct? This is an edge, this is an edge. So first hidden layer detects the edges in the pictures by comparing adjacent pixels. So it merely has to check if the RGB value changes from this pixel to this pixel, correct? In adjacent pixels. If the RGB is red, green, blue, as you know, each digital pixel has an RGB value. If the RGB value changes between two adjacent pixels, that means there is an edge here, correct? This is how the first hidden layer detects edges, and the second hidden layer combines these edges and forms starts learning corners and contours. The third hidden layer, combines the corners and contours and starts detecting parts. For example, this could be the eye, or this could be the head, and so on. Correct? And the final hidden layer concatenates the object parts to detect whether it's a car, a person, or an animal in this image. Okay, so this is how a neural network does divide and conquer, and it is able to detect what is contained in the image. All right. So let me just clear this up. If you have any questions, you can ask me through the questions window. I'm going relatively fast in the interest of time. Okay. So some of the major applications in AI and machine learning, there are countless applications, but we have just listed a couple of high-level ones. So image, speech, and text, banking and financial services, healthcare, of course, self-driving vehicles, and even two-wheelers and cars, and of course robotics. Okay, so countless interesting applications of AI and data science, and we are very excited about the upcoming revolution in this area. In next 20 years look extremely exciting around concepts of AI and data science. Okay, so let me just take a pause here. Uh, okay, well, let me cover a basic concept of. I see a question here. Let me see. Just a moment, please. Okay, Q&A can be done in the end. Fair enough. Sounds good to me. So, just a quick, different description of traditional, IT systems development process versus, machine learning process. So, traditional analytics or traditional IT systems development or software engineering, as we call it, we used to follow this SDLC or software development lifecycle process, where the business analyst or the product manager provides us the problem with problem description or product specification, and this is sent to the IT team or the technology team. They hardcode the rules of the solution in the software or the IT solution, and then they send it to quality assurance team, QA or quality control. If quality assurance team passes the software and says it is behaving as expected based on the test cases, then you simply put the IT solution in production, correct? Now, if there is some problem in quality control process, quality assurance, then we send it back for reviews. This is your traditional software development lifecycle process, or SDLC as we call it, or you can also say traditional data analytics process. Okay, so all the rules are hard coded by the IT team in the in the solution. Okay, some of you who might have worked in the IT industries might be quite familiar and adept at this, but it's quite easy to understand. Now, what is the difference in machine learning? So that's a question we are trying to answer. So what happens here is the process looks remarkably similar. However, instead of hard coding the rules of the solution in the program, we are feeding, historical data. As I was saying, historical data is input X, output Y. So sample number one, sample number 2, and so on. So I could feed, let's say, 10,000 samples or a million samples. All right. So more the data, more better it is. Correct. So if the data is high, more in size, then the model is more likely to be accurate. For example, predicting diabetes for healthcare patients in India, right? Predicting diabetes. So what would be the input features? The lifestyle, the amount of sugar intake daily, the amount of exercise, right? Sleep patterns, and diet patterns and so on. Those will be all the X features. And what would be Y? The probability of developing diabetes, correct? So X and Y. So our model, it will basically look at historical data. It will reverse engineer or learn the relationship between input features X and output feature Y. And then once we have learned the algorithm in the training step, we'll send it for a testing step. So there's a testing step in machine learning, and there we'll be testing this hypothesis, as we call it, whether this hypothesis is correct on new test data. Okay, so we will be feeding new kinds of X here and seeing if it is able to predict the correct Y. If it passes the test, we simply deploy this trained algorithm or trained model into production. If it fails the test, we send it back for review. So bulk of the process looks very similar to the previous traditional IT systems development process. The difference being here, we are training, so difference is here, we are training the model with help of historical data. Okay, so this is the difference between traditional, say, data analytics or software engineering and the new machine learning process. Simple enough. Let me continue. So I think we just discussed this. So you can see here that the first step in machine learning process, we have to prepare the input data in a certain way so that it's clean, efficient, and relevant. Okay. And then using that data, we train the model, and then we pass the trained model or trained algorithm to the testing step. If it passes the test, we put it in production, and otherwise we send it back for review. Okay. Now you can see here I'm feeding training data, XY data, and during testing step I'm testing with new kinds of test samples, right? All right, let me continue here. So just one slide on algorithms, then we'll go to some career topics in AI and machine learning. So some of the major algorithms are, listed here. Let me briefly just have a liner on each of them. Just a moment, please. Yeah. So what is regression? Regression is the process of finding line fits. So this is my historical data, given to me. Those of you who are from business analytics or data analytics, this will be fairly trivial for you. So we have been doing this in Microsoft Excel since ages. So we have, these data samples on an XY chart, X representing the input or the independent variable, and Y representing the dependent variable, right? So X could be the healthcare patients dynamics, and Y could be the probability of developing diabetes, right? And so I could find a line fit which satisfies the points. So the line fit equation would simply be something like this for a linear regression. If it is a linear line, it will be yx plus b. I'm sure this is a familiar equation for most of the folks because we have studied maths at least till our engineering or college or science graduation or whatever it is, or BCom, and definitely to high school and 12th grade. So it's basic maths, and so this is called linear regression, and we are trying to find the equation of the line which satisfies most of the dots. So this line fit process is called regression. The line could be slightly curvature also. This is called polynomial regression. This would be a 2-degree, and this is 2-degree polynomial, this is 3-degree polynomial, and this is a 4-degree polynomial. What do I mean by that? The relationship is slightly more complex, and it is x to the power of 4, fourth degree polynomial, correct? And here is x to the power of square, x square, and this is x cube simply, correct? Now classification is just a variation on regression. In classification, I'm doing the same thing. I'm finding the equation of a line. However, I'm only interested in classifying, sample classes into classes A or B. Okay. So if the samples lie to the right of this learned model, this line, then they are in class B. If the samples lie to the left of this model, they are in class A. This is called classification set of algorithms, correct? Clustering is simply clustering samples into categories. Okay. And in clustering, we don't have Y information. We are given X from historical data, but no Y. So we cannot do regression or classification the traditional way, but we can still, create clusters out of that X data, like groups, if you will. So this is called clustering. It's called unsupervised learning because Y information is not available. These two are called supervised learning. This is unsupervised learning. And finally, deep learning. So deep learning is an extension of classic machine learning. So all these form come under classic ML. This is deep learning, and this is the third kind of machine learning called reinforcement learning. So one, classic machine learning, deep learning, third kind of machine learning, reinforcement learning. What is deep learning? When the relationship between X and Y is sufficiently complex, and the pattern between X, the relationship between M and XY is very hard to model with classic ML. That's when we deploy the firepower or horsepower of deep learning. So deep learning divides the problems into neural layers, as we saw in the previous slide, and finds these infinitesimal relations. So each consecutive neural layer pair is able to model the tiny relation which I am drawing here. So each line segment here, each infinitesimal line segment becomes a pair of consecutive neuron layer. Okay, that's how the neural network works. So it just extends the idea of classic machine learning, but it divides and conquers because now each pair of neural layers represents the relationship of or this infinitesimal line segment. So by combining multiple such tiny relationships, I am able to model the relationship between X and Y, even though the relationship is quite haphazard, if you will. Okay, so I'm going really fast here, but hopefully this is comprehensible in interest of time. So the third kind is reinforcement learning, and this is used in robotics, gaming, and these kind of applications, driverless cars. So here we train algorithms by giving them digital rewards. So within the program, we hard code some kind of reward mechanism, and the program learns to repeat certain kind of desirable behavior because it tends to get rewards. So we train video games, we trained, driverless car. We also train robotic arms using this mechanism. So this is a newer algo which is evolving now, and some recent innovations is putting this in limelight as well. Okay, so all right, so let me just keep going here. Okay, so I think we sort of can take a pause here, and I would like to now discuss some career counseling topics. Okay, so you can see here we are showing various careers available in AI and machine learning space. Okay, so there are two good tracks. So if you are a technical person having a software or IT, background, then you can choose to be a technical data scientist or technical AI, engineer or technical AI analyst. And here there are various kinds of streams like this big data, Hadoop, Spark, Kafka, Hive. There's also things like there's one more box here actually. I should put that here. Things like Tableau. Folks who work in traditional, business analytics domain, they are very good at Tableau and SPSS and Cognos and so on, right? And SAS. So some of the folks from your group may be familiar with Tableau or SAS or SPSS. So there are three kinds of streams in the technical track. This is reporting and visualization of some data science. This is big data management using Hadoop, Spark, Kafka, Hive cluster, and this is of course ML and DL, which is comes under the artificial intelligence. So if you want to leapfrog technology, I would ask you to jump here directly. And you are happy to connect with me offline. And if you have any questions, just reach out to me. I'm happy to counsel you one on one and help you in choosing a career and a training path, in this space. Okay. Now, if you are not a technical person, there is we train AI to managers as well, the managers can also become specialist AI consultants or AI generalists, and so these folks could come from any background: sales, marketing, ops, consulting, program, product, project management, QA, technology, marketing, even human resources. Okay, so in future, I believe everything is going to get specialized. You cannot be a generalist anymore. You cannot be a general sales manager. You cannot be a general HR manager. You will be AI HR manager. You will be AI sales manager. You will be AI program manager. And to become that person, you will have to specialize in artificial intelligence, machine learning, and its various forms. Okay. The concept of generalist is now disappearing from the word. So this is very important point. It's all about specialization. So you have, even as if you're recruiting human resources people, you are HR manager, you have to be a specialist in that domain to be able to do effective recruiting. Okay. So domain knowledge will become supreme, and the HR role or the sales role or the business development role, marketing role will become a sort of a conjoined role, but the domain knowledge will become a critical for that person to be effective, because going forward it's all about specialization, not generalization. So we train AI for to managers, cross-functional managers also, and we have done many such programs in variety of corporations. Currently, I'm taking classes for in AI and data science for BCom, MCom, chartered accountants, investment bankers, MBA, multiple MBA colleges. This is a pattern we see, and now many MBA colleges are beginning to teach programming courses like Python and R, because the fundamental belief is that that can enable those professionals even better to operate in these new areas. Okay. Okay, so that was a quick, very quick introduction to the overall field of AI. In interest of time, I'll just stop here and open to questions. So my company is in the process of intense training in AI, machine learning, deep learning. I teach, Python-based machine learning and deep learning. Uh, and by the way, we run an AI lab. I really like to introduce you to my AI lab. Just a moment, please. So this is really, really, innovative stuff what we do. And we have something called an AI lab. Uh, so in Bengaluru, we run an AI lab, and basically we do a meetup every Saturday. Even today, there is a meetup after some time. So in here, what we do, we work on cutting edge AI innovation. So we invite data scientists from variety of companies, and we are working on most cutting edge of algorithms and AI and machine learning space. And I'm just showing you a couple of products we are developing. For example, in image processing, style transfer, animation of images, for media and entertainment, pose detection for augmented reality, virtual reality, uh, and face and object detection, and visual search, text captioning of photos and videos, and social media trend detection, stock market predictor, and variety of interesting data science and analytics applications. Okay. So this is a most fascinating concept, and we are very excited about what we are able to do with the cutting edge AI innovation. And we have a team of 30 data scientists from a variety of large and small companies who come to our lab and working on. We have teams working on different projects like this. Okay, uh, so let me show you a small demo so that will give it better perspective. Then I'll be open to questions. So I was telling about style transfer. So I can take the content of this image. It shows a bird, I think a kind of sparrow, if I'm not wrong, not sure. And I take the style from this image and I superimpose it. So this is using something called GANs, or generative adversarial networks, a specialized form of artificial neural network. So this can be used for creating new content, this technology. For example, writing new novels, producing new motion pictures, producing art. So we won't need Michelangelos and Picassos anymore. We will not need movie producers anymore. We will not need content creators anymore. We'll be generating new text, new video, new audio. We won't need musicians anymore. Okay, we'll be generating by machine everything now going forward. So over time, you will see more and more of this kind of innovation. Okay. So this is face detection protocol. So, a very popular pop serial called Friends. So I used to really like the serial in slightly younger days. And for some whatever strangest reason in my midlife, I'm watching the serial again. So you can see we are doing face detection on Friends characters, and at the top, you can see we are able to do it at certain frames per second rate. So the speed of the video matters for us to be able to intercept and capture the face and use computer vision to pinpoint the character. Okay, and this is using an algorithm called OpenCV and deep neural networks. Okay. Okay, I think I'll stop at that. Now I'll take quick, two, three questions because I have a hard stop in a couple of minutes. So let's take up some questions now if you have any. Kindly, very fast because I do have a hard stop in like 3, 4 minutes. But I'm always available to talk to each and every person one on one as well. Just reach out to me on LinkedIn or WhatsApp. You have my number. I'm very available and communicable. So reach out to me. I'm happy to counsel each and every person individually as well. Any quick questions for the session today? Actually, I I don't have time to enable the mic. Akhil, I suggest you put it in the questions window because it's very hard to understand folks on the other end. Uh, all right, so thank you for your time. It was great. I hope you enjoyed it. Uh, I look forward to seeing you in the next webinar.